Okay, hello everybody. So it has been a good while since I have made a chem video, and I just figured that I would do one right now. So let me tell you a little bit about solutions. Okay, so here are some terms. So a solution is going to be a homogeneous mixture composed of at least two substances, okay? So things like air or Gatorade are going to be solutions. Solute is the thing that dissolves in a solution, and a solvent is the thing that does the dissolving. I included this equation down here, solute plus solvent equals solution, because in some of the calculations that you will do, they're going to ask you for like the mass of the solution, and if they don't explicitly tell you the mass of the solution, you're going to need to sum the mass of the solute and the mass of the solvent in order to get that. So just keep an eye out for that. I also threw in salt. So salt, we might think of table salt, right? You know, sodium chloride. But in chemistry, a salt is really just anything that is a cation plus an anion. So, you know, something like lithium fluoride, that is going to be a salt. Silver chloride is going to be a salt, those types of things. Okay, now let's look at dissolution. So the main idea here is that like dissolves like. So if you have something that is polar and another thing that is polar, you know, those two things can, well, the solvent can dissolve that, the polar solvent can dissolve that polar solute. If you have two things that are nonpolar, same thing. So let's look right here. This is going to be our ionic compound dissolved in water. So all ionic compounds are soluble in water to some extent, but some will not completely ionize. Some might ionize just a tiny bit, but still, all ionic compounds are soluble in water. So here what happens is you can see that we know that water has a partial positive and a partial negative. So it goes towards the positive sodium ions with its negative side, and vice versa for the negatively charged chloride ions. Now let's look at this. So this is going to be a sugar compound breaking up into sugar molecules. So this is a little bit different here because sugar is covalently bonded and water is also covalently bonded. So what happens here is ions are not formed. Those covalent bonds are going to remain intact, and therefore we have a solution which is not charged at all. Back here, we're going to have, you know, Na plus and Cl minus in our solution. So there is a charge there, but here everything is still neutral, okay? I also want to note that this is a physical change because if we can imagine our chemical equation, that C12H22O11 for our sugar is still going to be C12H22O11 after it, you know, kind of just separates into smaller things. Now, this is a little bit of a different case. This is oil and water, and if we recall, oil is non-polar, and since water is polar, those two things, nothing is going to be dissolved here. Okay, now this is kind of the cool point of, oh, dang it, that's really too bad. Can I move this? Okay. Why am I, well, okay. So electrolytes versus non-electrolyte solutions. So basically an electrolyte is a substance that dissolves in water to form solutions that can conduct electricity, okay? So the most important takeaway on this slide is this stuff right here. If something completely ionizes, it is a strong electrolyte, okay? So strong acids, strong bases, soluble ionic compounds, those completely ionize and they are great for conducting electricity. Something that partially ionizes is going to be a weak electrolyte. So things like weak acids, weak bases, and insoluble ionic compounds are going to partially ionize. They can conduct some electricity, but not as much as those, completely ionized things. Now, if you have no dissociation, there's no charge in that solution. So those are non-electrolytes. Nothing is going to be able to conduct electricity there. So I have covalently bonded molecules. As an example, we can think back to our sugar, right? Okay, now let's look at this. Classify the following as strong or weak electrolytes or non-electrolytes, okay? So go ahead, pause the video and give this a go. Okay, let's see if we are on the same page here. So let's look at each of these. HCl. So I can remember that HCl is one of my 6 strong acids, so this is going to be a strong electrolyte. Lithium hydroxide. This is a metal hydroxide, and metal hydroxides are strong bases, so this is going to be a strong electrolyte. Hydrofluoric acid. This is not one of my 6 strong acids. This is a weak acid, so therefore this is going to be a weak electrolyte. PbCl2 is going to be a weak electrolyte because this is an insoluble ionic compound. So yeah, even though it's insoluble, but there is still a tiny bit of ionization. It partially ionizes, so that's a weak electrolyte. Now CH3OH, this is a non-electrolyte because this, this is like our sugar example, right? Is anything here going to break up into ions if we were to put it in water? No, so therefore this is a non-electrolyte. Strontium hydroxide, once again, this is a metal hydroxide. This is a strong base. This is a strong electrolyte. Okay, so I hope that this video was helpful, and yeah, that's all I have. Thank you.